Tōna koutou no mai hoki mai ki Branching Out, the podcast where we discuss Indigenous forestry in Aotearoa. Today we're welcoming Heidi Dungey to talk about genetics and breeding. Heidi is a senior scientist who worked at Scion for over 24 years and has been a breeder for even longer. Welcome, Heidi. Tēnā koe. Thank you for coming in today and talking with us. First of all, I just wanted to say thanks for hiring me. I started here as a Māori intern when I was 20 and you brought me in, and then I said, hey, can I have a job when I finish studying? And you were like, yeah. And I was like, oh, cool. Thank you. That's awesome. So a big mihi to you. Could you give us a bit of an introduction about yourself? You're a researcher, you're a breeder. What's your background? Where are you from? What are you interested in?
Kia ora, Ki-Taurangi. It was an absolute pleasure to recruit you, by the way, and I'll do it again in a heartbeat. So, my name's Heidi Dungey. I'm originally from Tasmania. I worked at Scion for 24 years, just a little bit over that for being in New Zealand. I always wanted to be a dock ranger, to be honest. Nobody probably knows that. I did a degree in plant science, but I did a few weird things on top of that. I did horticulture and I did a bit of study on plants, plant pathogens and insect pests as well. And then there was no jobs because it was the middle of the 80s. So I ended up falling into genetics and getting a scholarship to do a PhD on tree breeding. So that's kind of how I fell into it. And ever since then, I guess my passion for trees has kept going, and the forest and ngāhere. From there, the first job that was available was a 2 to 5 year position in Chile, and it was being a tree breeder at La Cooperativa Mejoramiento Genético, which is a breeding cooperative in the Southern University in Valdivia. So I worked there for just over 2 years. I was working on tree breeding of Pinus radiata and Eucalyptus globulus. And of course, at that time, they were starting to do some breeding of one of their Nothofagus species. So I really always thought that that was something that we should be doing, is actually growing our own native trees for timber as well. So I've always hoped to get back to that. That was probably part of my initial inspiration. And then I ended up going to Queensland for 3 years, and I spent 3 years as an intern working on hybrid pines, Pinus Aotearoa hybrids, and also a little bit of eucalypts and a little bit of their hoop pine, which is a native hoop pine, when I could squeeze it in. And I guess after 3 years, my partner at the time couldn't find a job in rural Queensland, so we moved to New Zealand, and I came to be the radiata pine breeder for the radiata pine breeding program. Actually, unfortunately, soon after I got here, that breeding program was transferred over to the radiata pine breeding company, and so I ended up doing a whole lot of other things, including some tissue culture research, alternative species to radiata, a little bit of Indigenous with Greg Stewart, who you've interviewed previously, and as many things as possible, really. And I was lucky enough to do research and learn things like forecaster and timber research on different species, including, timber shrinkage. So my career at Scion's now been 24 years, and I'm just about to move to PF Olsen, so that's pretty exciting. But I think it's been a really amazing experience to be able to broaden my quantitative or tree breeding background with all that happens at Scion, from basically seed to product. And that's been really important for me. Really, really enjoyed it.
Yeah, I mean, it sounds like obviously you've had quite a big journey and you've had your fingers in many, many pies. I guess my next question for you is, what's your favourite part of your job? What's the part of your job that you're like, yes, I really love this part brings me joy, it makes me want to get up and go to work?
I think the most important thing for me is to be solving a problem and see the results. So I think applied research. I like the impact. I also like the people aspect, so I really like mentoring and I like fostering new talent, and I also really like pushing the boundaries.
Yeah, you're a bit of a boundary pusher.
As you know.
Yeah.
So I like to challenge the paradigms that are in place, and I like to start getting us to think a little bit outside the square and some other possibilities. Even if they're wrong, it doesn't matter, just to test them.
Yep.
And to see if we're actually going still in the right direction.
Well, that's the thing, right? Like, debate makes for really good research, or actually really kind of challenging and pushing ideas and people out of their comfort zone. You've said that you've worked lots on pines and you've kind of gone to different areas in the world and eucalypts as well. So, you're kind of working more in an Indigenous space now, right? So what kind of inspired that?
I think, I have had the pleasure of working on radiata pine and had a depth of knowledge that was possible because of that. But I always felt when I came here that there wasn't enough forest across the Motu, particularly in the lowland areas. What forest there is exotics. And so I was thinking that it would be an absolute pleasure to be able to try and make a difference and inspire New Zealand to plant more natives at scale. Yeah.
With your experience with sort of temperate and subtropical pines and eucalypts, how has that shaped your approach to breeding with Indigenous species?
Yeah, that's really interesting because tree breeding is often viewed as purely commercial, but actually it's just a mechanism of managing biodiversity or diversity within the species. So really you are managing how much relatedness there is in the populations and how you can actually select for the traits you want. And traits for a commercial sense are like growth and form and wood quality. But if you are thinking about other things like biodiversity, it might be how much does it fruit? How many branches does it have for different types of animals to have their home in it, So it's all about taking an approach that's from a conservation or a different perspective than a commercial one, really. And I always think that conservation as well needs a little bit of challenging. And here I always am thinking to my own experience as an Australian and the fact that, the Indigenous people there have been there, some say nearly between 75 and 100,000 years. And I listened to some narratives by a guy called Tyson Youngporter, and his narrative is around active adaptation. And I think that rather than conservation, that's kind of a paradigm for us to consider, particularly under climate change. So I guess I take my experience of the eucalypts because for me as an Australian as well as a New Zealander, they're kind of native, and how you would probably try and manage them in an active and adaptive way for different potential outcomes.
Yeah, it's interesting you say that because we've been having conversations around, phenotyping for cultural uses. So we know that when it comes to sort of looking at a phenotype of a tree for commercial purposes, like you say, it's really based around growth and form. Recently, we've been having conversations with carvers, with multi-seed collectors, with people who develop marae and papakainga, and kind of asking them like, hey, do you guys value the same tree traits as these commercial growers? Do you want them to be the same? Or, if you're a carver and you want to carve something specific, do you kind of always just want a tree that's really tall and grows fast and all that? And we're actually getting different answers, right? And so it's coming back to what you're saying is it depends on what you're breeding for, and it's not all about these commercial kind of values. So I think that would probably help people in different communities to kind of grow a little bit closer to the idea of breeding, because I know that can be a little bit scary for people, eh?
Absolutely. And if I just wanted to add, essentially that's what they're doing with kiwi and some of the other rare birds that we've got. They're actually managing the diversity and selective breeding of those things to maintain the population. The same thing could happen with trees. And actually, as climate changes, and we've got a lot of disconnected populations in many of our plant species, so actually managing some of how they actually move across the landscape. And it doesn't need to be in a particular manner. It can be managed by whoever, I think could be actually really a concept that we should test.
I guess taking a bit of a step back, just for listeners, what are the benefits to having a diverse genetic population? Essentially, why is breeding so important?
Yeah, breeding is important in the context that really it's basically managing genetic diversity, and genetic diversity allows you to have resilience in the long term of maybe years and years, in particular when many people think about that, it's resilience to challenges about the climate, so maybe drought or too much water, but also resilience in terms of pests and pathogens that might come in. For example, with myrtle rust coming into the country, we actually don't know a lot about the genetic diversity of the affected trees and how they're actually being affected. And this is quite interesting because if you look, even at a shallow level, the amount of research on any New Zealand native tree is really, I struggle with a word there, but definitely there's a paucity of information where we're trying to make decisions and we're making decisions based on no information. And sometimes they're overly conservative, and perhaps sometimes conservatism is really a good thing if things are going to stay the same, but climate is moving fast. And it's a real test of our skill as a population, I think, to work out how on earth we're going to help the forest if we need to.
It's almost like the lion's share of funding is going into our commercial species.
Yeah, and that's again, I guess, because that's how the government has always seen our resilience as a country, is through the commercial resilience and our net present value or our gross domestic product and our exports. So it's very difficult to value what an Indigenous forest is worth, except in a production sense, in the more traditional sense of value as well. So I know there's a lot of work trying to dig into that. Even if we start thinking about, well, if we do adaptive and active management of forests, perhaps we can also help quantify its value in many ways, not just in the commercial sense of words, but in the cultural and society's need to be in forests and around forests and gather food from forests. It's so much deeper than just a shallow commercial kind of lens.
I understand what you mean, because I've been working in that space myself of trying to quantify cultural and societal values is really quite hard. But, we're getting there. I'm seeing more and more research in that space. So I'm kind of hoping that it just keeps ramping up and we all kind of get a better collective understanding of the value of these trees, right? How do alternative species fit into the concept of Indigenous forestry, and what role do they play in improving forest resilience?
I think there's always going to be a place for radiata pine for many reasons, but it is 90% of our planted exotic forest. And I think that that's a challenge for us because with climate change, something may happen which would put that at risk in terms of biological pest or pathogen coming into the country. So I think alternative species offers a risk mitigation to that in terms of our forestry industry, but also many alternative species have higher quality timber. They have possibly better economic outcomes for the same area than radiata pine, and they also open up new markets for the wood if they actually were chosen for harvesting. You can even have a lot of forests for climate mitigation through carbon sequestration, but remembering forests planted now won't quite help with that because they don't actually grow fast enough. But ultimately, that sort of adaptation is going to be a combination of technological adaptation as well as forests. We still need them. I think on farms, it would be really, really lovely to see how we can work together to maximise the future for our mokopuna and maybe some carbon sequestration on farms that balances the farm carbon liability, I guess.
Yeah, definitely. I think there's quite a lot of opportunity in that space. And again, it's another sort of area of growing research, hey?
Yeah, and Indigenous forestry, well, I think on farms, it's definitely got a lot of potential. And just across the whole of New Zealand, we need to consider it because if we don't, this is our big opportunity, I think, to really change the paradigm of what we want our future forestry to look like. Our current forestry paradigm is around one species and it's fantastic, but if you go to other countries, you can have actually multi-age, multi-species forestry. It's just not as profitable and there's a trade-off. But if you add other things like tourism, gathering of kai, all those other added benefits, then actually, yeah, there's possibly something that we could build for our future that would be even more valuable as a country.
Holistic sort of multi-use kind of thinking.
Yeah. And the interesting thing is we did actually test a lot of exotic species. We tested heaps when they first realised that basically they're going to run out of native forests. They kept going, they're actually going to run out, which is shocking, hey? They actually tested maybe 50 to 60 different species and they chose radiata pine. And there were a lot of collections out there. A lot of them still exist in the active kind of germplasm plantings, I guess. So they're out there as a backup. But yeah, perhaps it's time to maybe reevaluate some of these opportunities. In China, I was there last year. I was lucky enough to visit one of the universities, and they're doing like ginkgo, magnolia, eucalypts. The range of species is incredible, and the amount of money they're throwing at this is also incredible. So I think we need to kind of take a bit more of a global view in how we're operating and think about more markets than just the one that we're currently in.
What are some of the most significant challenges that you face in genetics and breeding of Indigenous trees?
I guess it's the fear that doing breeding is actually somehow manipulating the genome, and actually it's not at all. It's just like crossing using natural processes, pollen. You put the pollen on the cone and then you collect the seed, and that's basic as breeding gets. You can even do really basic breeding by doing what's called mass selection, where you do a planting and then you take your selections from that. I think the biggest barrier is actually a misunderstanding of what breeding is. And I think because it's associated with the genetics word, and genetics automatically brings a lot of fear, but all genetics and breeding is trying to figure out which part of the variation that you see is actually carried forward in the generations. And that's all the tree breeding is doing, is saying, yes, this trait will carry part of its trait forward in this percentage. And normally it's about 20%, 30% of what you see is genetics and the rest is environment. The reason we put things in trials and replicate them is to try and figure out, is the variation due to environment, or is it from mum, or is it from dad, or is it from the grandparents, sort of thing?
Nature or nurture, eh?
Yeah, so really a lot of the time most of it's environmental variation, but you'd be surprised what you can do with a small amount, like even 10%, which has been a heritability or amount of genetic variation of diameter at breast height, which is a current New Zealand forestry measurement standard. That's only 10%. Yet we've made quite a lot of improvements in that over the years. It's really very simple. It's not scary. And if you compare it with like using genetic markers, again, people get quite frightened of that because you're looking at the genome. But actually what you're doing is looking at markers across the genome, but you're not actually changing any of them. You're using them to correlate it with the trait. And then you're using those markers where you don't measure the trait to predict the trait. So there's no intervention at all. If you do more science, you can learn, that marker there actually helps to grow you a little bit more. It will help be more resistant to this pest. And you can do more informed selection using that. And then after all of that, then there's the more genetic engineering type approach, and that's the scary one. But even that's become less scary because everything that they do can be very precise, and it's no longer just taking any DNA and shooting it into the genome. It's having knowledge about the genetics and the genome, saying this sequence affects that trait, and I'm just going to change one little thing which will turn that on and off. And it's actually no different in theory to what may happen in nature from a mutation. So it's much more comfortable, I think, to have that conversation.
Well, even that word, though, is really scary, mutation. And it's like, man, that's how we got here.
Evolution equals mutation, right?
Yeah.
Yeah, totally. There's so many mutations that bring us disease in humans, for example. Most of it's quantitative, which just means there's lots of little things that contribute to that disease. It all adds up. The paradigm that one gene equals one trait, I don't think actually exists, or it's very rare.
That's interesting. I mean, the thing is, we've been breeding for thousands of years, right? Our ancestors were breeding and their ancestors were breeding.
Yeah.
And maybe you want to give some examples around that we've gone through breeding with foods.
Yeah, corn, wheat. Yeah, I find it fascinating. Even kumara. So that wouldn't have been intentional, but you always select the best ones to go forward into the next paddocks or summer. So There's always been some sort of farming, and in that farming process, that's where you do some selection, which is essentially a form of breeding. And even some of the narratives I've read from some of the books written by Indigenous Australians have said that they actually farmed the native yam for many generations. And actually, they said there were lots and lots of really beautiful fields when the Europeans first came, and they just thought that that was like wild. But actually, many narratives are now correcting that and saying actually they were farmed.
Targeted effort.
Yeah, so I think it's in our nature, I think, to nurture these types of food plants. And we could look at the forest as a source of our own food for our health, I suppose.
It's that kind of holistic thinking that you were talking about. Could you explain the concepts of quantitative genetics and hybridisation in the context of tree breeding?
Yeah, so quantitative genetics is just what I've been talking about. Really, it's breeding using measurements and lots of them, so that you can look at the variation of the trees. And what you do is you have lots of families, and a family is just one mum and one dad, and you have lots of babies of those families. And then if you measure them all, and there has to be thousands to be able to do it properly, you can look at the variation within a family and among families and then among ancestors and partition that total variation into which comes from where, and the environment, of course, and then the genotype by the environment interaction. And that's basically
where the magic happens.
Yeah, it's called, everybody cracks up, but I call it bucket chemistry, because really it's you throw it all in there and it's all about averages, right? Most people will laugh at that, I'm afraid.
No, it's pretty funny too. How do you assess and select for desirable traits in Indigenous tree species, and what metrics do you find most useful?
The procedure for selecting in Indigenous trees can be exactly the same. You can use exactly the same principles. However, the best thing to do is have the conversation with the owners or the kaitiaki of the Indigenous trees and to adapt your methodology to what is more going to fit what they want. And a good example, I think, is mass selection for many hapu will be really attractive, because you won't have to plant things in rows and quantify all the variation. You could probably just do a simple breeding by just planting a whole lot of families out and then saying, yeah, I like that one, and take them forward to the next generation. I think that it could be that simple.
Can you share some of the key research outcomes you've achieved, that have benefited the forestry industry?
Well, I think tree breeding itself, there's a couple of papers that are out there. I can't remember the exact number, but tree breeding in the first two generations or first generation has been shown to realise over $3 billion of value to the industry. I may be a little bit off there, but it's quite a lot of money, a large amount of money. It really is worthwhile pursuing, and there's been a lot of concern, I guess, that is that all we're going to get? But actually, if you look at maize, it's been thousands of generations. I think we're only 2 or 3 generations from wild, so I think there's a lot more that we can do if we want to.
Yeah, it's a good point putting it into that time perspective. So thinking about that, how do you approach seed to product research, and what steps are involved in that process?
Yeah, I think as a tree breeder, you're always thinking about the whole value chain, because you want to breed for the best outcome, whatever's desired out the final product. The product could be just a forest that's multi-species, multi-age. It could be the most dense, most amazing timber that you've ever thought of, or it could actually just be you want something that's good for surfboards, so a little bit like balsa wood. So from seed to product is really important for breeding. You've got to be thinking about that end product. If you're not, then you missed your calling, really. So I think you go to the end product first and then you come back. How do I actually breed for that? What are the traits that are important? In fact, we even sometimes do what we call economic weights, which will allow us to select for the right thing at the end of rotation rather than the selection trait like diameter.
Okay, that's interesting. And so before you mentioned, that you'd done some mahi around sort of insect and pathogen interactions, how does the interaction of insect and pathogens influence your breeding strategies for Indigenous trees or exotic?
I think I've done a lot of work on hybrids actually, and so I might start there. And so hybrids are quite interesting because they're really a natural phenomenon. In eucalypts, for example, there's a lot of theory that they're actually still speciating, and, there's over 700 species by some classifications. But if you look at the species in inverted commas, they're actually like species complexes, and they all kind of naturally integrate. And if you look at even some of the Myrtaceae species here, you can actually see the same sort of thing going on, even with Rohutu. If you look at Rohutu, there's actually kind of a natural hybridisation integrated with Ramarama, and if you also look at Rata and Poitikawa, that's the same. So I think, a species is kind of a little bit of an interesting concept in that Myrtaceae genera. And a lot of my research in the Myrtaceae genera, in the eucalypts at least, showed that hybrids were actually a lot more susceptible or more resilient to pests and disease. And you couldn't really pick it all the time. So it might actually be that hybrids are a pathway for survival for some of the species. And overseas it's been demonstrated, but I don't think we've even really looked at it that hard here. I could be wrong because I'm in forestry research rather than more ecological research, but I've always been fascinated about whether or not that might be a pathway for myrtle rust resistance in the host species, for example. And I think we've had some studies showing that a cultivar, which did look to be like a hybrid, possibly didn't get any myrtle rust. And so I think there's something there that we should look into further.
Yeah, I was watching a presentation by Michael Bartlett the other day, and he was kind of just saying that we need to take advantage of these opportunistic findings. Somebody had said that they had some myrtle rust in their backyard or something, and he just had this photo, and it was just this row, I think it was Rohutu, and there must have been like 7 or 8 of them that were just totally dead, and then one of them at the end just looked like the most healthiest, flourishing Rohutu, and he was like, we really need to be keeping track of individuals like this.
Yep, that's basically mass selection, right? You look out for the ones that are resistant and you put them together, make them have babies basically, and then your next generation will be more resistant.
And so is that how you would approach drought? Like if we've got an area where there's a massive drought going on and you've got 50 trees and 2 of them are still thriving, that's kind of the same concept?
Absolutely. And that's actually how you start a breeding program, full stop. So you go out into the field and make natural selections. For commercial, you say, oh, look, this big, beautiful, straight thing. But if you're doing resistance, you go out and say, oh, that one's green in a whole paddock or a whole stand of really badly affected trees. It's definitely a strategy that would work as long as you figure out how you're going to make the next generation. And I do think that's really important. We can't just leave it there isolated. It'll just probably breed with itself or not at all. So do we share pollen? Do we share seed? How are we going to do that in a way that's culturally safe as well, right? You can't just move things around without thinking about that. But ultimately, as a tree breeder, I'd probably say get all the resistance ones, put them together to make a seed orchard for the next generation. And they are going to be more resistant.
I bet you wish you just had like billions of dollars to set up all these trials and I bet you could have so much fun if you just had a ton of money.
Yeah, I think we've been lucky enough to work with Department of Conservation on a Jobs for Nature project and Rotuiti 15 on this, and we are finding that it might work. So working out how to mobilise that, though, across the country, and that's what I'd spend my money on, is mobilising that within every hapu.
Yeah.
It would be really powerful.
Yeah, and even just resourcing them to have that corridor with their people,
100%.
Yeah, it makes a big difference. Well, Heidi, thank you so much for joining us and giving your corridor today. We're looking forward to hearing more from you. And that's it for today's episode. Join us next time to discuss more about Indigenous forests and Indigenous forestry in Aotearoa. Mauri ora.